Morning, everybody. So, today I was going to talk about kind of a bit more of an in-depth subject today. This is going to be on serverless functions. So, some of you may know what serverless functions are, some of you may not, and I thought we'd talk a little bit about it today. So, let's get started. So, serverless functions. You may have heard about these, and let me just try to explain a little bit about what they are, and then you guys can go ahead and ask your questions about what serverless functions are and whether or not they're usable in your environment. Are they something that, especially if a lot of you guys are Access developers, maybe you're wondering, why would I even care about what this is in the first place? So I certainly don't blame you. Well, first of all, a serverless application, or I should say a serverless function, is essentially, imagine if all of your business rules, all the stuff that is a function in your back end, instead of having those functions being hosted by your application, like having your server actually host those API endpoints up, what if you could make each one of those functions just accessible online? So you don't have to run any sort of server. You don't have to run the framework. You don't have to make sure about installs. You really don't have to worry about these updates and pushing updates. All you really have to do is just manage one function at a time, and they're just kind of out there on the cloud. That's what serverless functions are. They're essentially every function that you have is you can put it up there and give it some way of connecting. Now, there's lots of different ways to connect to these serverless functions. The most common way, of course, is through like a web API where you have some sort of RESTful API. You're doing post, put, get, delete, that sort of thing. And there's actually three big names in this space right now. So the first one is, sorry, I'm trying to pull up a link that I forgot to pull up beforehand. It's got some information here, some goodies that I wanted to talk about. So there are three major brands in this space. There's Amazon, what they call AWS Lambdas, or AWS Lambda. It's weird hearing that term Lambda in that sense. It's because Lambda to me means something completely different. But that's what Amazon Web Services decided to call it. So, by the way, don't forget to drink your coffee, guys. Yes. I like mine with a little bit of cream and sugar. Anyway, so we got Amazon Web Services has Lambdas. You have Google Cloud; they call them Google Cloud Functions, and then Azure calls them Azure Azure Functions. So Microsoft with Azure, Google with Google Cloud, and Amazon with AWS. And really, AWS Lambdas were the first venture into this, and it became one of the most common ways that you're going to set up your Alexa to do special functions, right? You can program your Alexa to use these Lambda functions, or in the cloud functions. And you just basically associate like some sort of phrase, and then you pass it along to the Lambda function. The Lambda function then processes, and you have access to a variety of different services within those online functions. So there are some things to know about each one of these. So the main thing I wanted to talk about, though, before I get into like an article that I have found, the languages. So what programming languages can you use for each one of these? Because that's kind of important, right? Picking which one you're going to do, you got to have a particular language in mind. So all three of them actually support Node.js. So if you are a JavaScript developer, or you know JavaScript, and you've worked with Node.js, then you can work on all three of these platforms. You can build a AWS Lambda with Node.js, an Azure function with Node.js, or Google Cloud Functions with Node.js. They also all three support Python. Okay, of course, right? Python is becoming really, really popular. So with AWS, you've got Java also, Go, C# now, which is pretty cool that you can do C# with AWS Lambda, and PowerShell. So you can use actually PowerShell with AWS Lambdas. which is interesting. I still don't necessarily consider PowerShell to be a scripting language, but I guess it is. I don't know. With Azure Functions, you can do C Sharp, obviously, because it's Microsoft product. Node.js, F Sharp is... So C Sharp and Node.js are two officially supported languages, but you can do some other languages too, like F Sharp, Python, PHP, and of course PowerShell. Go figure why. Then there's Google Cloud Functions, which right now they only support 3 languages, and that's Node.js, Python, and Go. So for me, Microsoft guy, I liked Azure Functions. I actually saw a demonstration of Azure Functions. It's pretty cool. I really like the technology. So why would you want to go to this, right? So why would you want to go to this serverless function? And to me, I think serverless is a little bit of a misnomer. Like, there's still a server, right? There's still, it's just that the cloud is hosting it. Like, they have this platform that's already prepared, and all you have to do is just write your functions in that thing, and then you also tell it, you like dial in how you're going to receive those requests, right? But you just basically write a function. It's going to have a name to it. It's going to have parameters that you need in order to perform the job, and what kind of data is going to come out of it, and then you just type up what it's going to do. And you have access to several different objects that are on the server. You can actually interconnect several different functions, so you can have it, obviously if you have one that's like talking to some sort of database like Firebase or something like that, you can have that function go talk to a database and come back with data, that sort of thing. But it's sort of like having these tiny little microservices, right? It's like taking the concept of a microservice down to its smallest possible level. Because with a microservice, you're typically making some sort of domain or some sort of service that is oriented around a particular domain. Like, this is, and when I say domain, I mean it in the software development world, not an IT world, right? IT world domain means basically the entire infrastructure of the network for your company. But for programming, domain means like this service has these certain things that it manages and controls, and that's its domain. So they're kind of taking it, if you think about serverless functions, it's like an individual function is its own domain. It's really like nitty gritty. Why would you want to do this? Well, the reason I think is because it essentially alleviates you from having to worry about those updates, right? Worry about like which .NET framework am I using, or is somebody going to have a framework installed? Are they going to have Go installed, or actually you don't really need it for Go, but like a .NET framework or the Java runtime, which is the Java VM. So do you need those things, right? Do you need those things on the computer that the person is running, or on the server, and keeping that stuff updated on the server? All of that is handled for you. Like, they're already managing all of that. All you have to do is just go right into their website, write the code, and it's done, right? That's really cool. But some of the pitfalls are there too. So how do you manage that? That's really kind of the biggest one for me. I think, how do you manage all of these different functions that are spread out across this, across the world, basically, right? On this cloud, how do you like manage each one of those codes? Because you can't just tap into some sort of source code. You can't just post it up on GitHub, right? You can't just manage it on GitHub and then post it. Although I think there's a lot of inroads being made into that, it's still not quite there. It's still not quite a fully developed source code, source manage type of thing. I don't see any questions yet already. Wow, okay, I must be just doing a great job of explaining. So, with these pitfalls, some of the companies, there's a lot of companies that are starting to take this on. It's one of those new hot topics, right? That programmers are really enjoying the technology. They like it. They're like, hey, we should do this. We should do this for a lot of our stuff. Yeah, it's okay. And I think that what you're starting to see is that upward trend is starting to flatten out a little bit. It's not on a decline. It's just kind of starting to taper off a little bit, as I think more and more companies are coming to this decision of, do we really want to be on the bleeding edge of technology because this is expensive? How long are these services going to last? And then, of course, there's like the main programming challenges. How do you manage the source control for this kind of stuff? So there's a lot to be concerned with. You guys can hear me okay? Yeah? Okay. Yeah. So there's a lot of things to be concerned with. In a lot of companies, and I came across this article that was by ZDNet, another one of my little stashes. And this is from Joe McKendrick. I'll send you guys the link. I'll put it up in the description a little bit later on. But essentially, serverless computing, seen as the next evolution of cloud, IT professionals have been taking a more cautious line with this approach. So they're starting to get, IT professionals are starting to like, hey, wait a minute, this is a great idea, but let's figure out if it's actually a good solution. Serverless computing is where backend computing functions are managed by a cloud provider. So you just have like I said, your back end, your your API endpoints, you basically just put them up on the cloud and you don't host them on a server. You're not running some sort of hosted service that you are dropping your source code into. Instead, you're just taking that one function and you're basically dropping it in and you're saying, okay, this function will be accessed via, HTTP API or something like that. Okay, so in last year's survey, 19% were using serverless in their organization. So 19% in this survey, 19% of companies were actually using serverless. But now that number has slipped to 15%. Okay, so it's starting to really taper off. Currently, 36% report evaluating serverless compared to 42% in the previous survey. So now companies are slowing down on even evaluating it as something that they want to do in their systems. For users and evaluators, 18% say they are broadly deploying serverless across the entire company. So the companies that are currently already using it are expanding it. Okay, so that's one of the other things. So for users and evaluators, 18% say they are broadly deploying serverless across their entire company, which is double the percentage who said that they were doing it last year. So like, if you are already checking it out, you are expanding on it. Whereas the number of companies that are looking at it and the companies trying to figure out if it's something they want to do, they're pretty much starting to taper off. Like the companies that want to make that move have made the move and they're branching out. Companies that are just trying to figure out if it's something, those numbers are starting to taper off. And that's something that's really important to pay attention to, because that's going to help determine whether or not these providers are still going to continue providing this as a service. I don't think that they're going to cut it off. I think it's going to be one of those things where if they do decide to turn it off, it'll be a very slow turn off. But there has to be some sort of profit in it, right? There has to be some sort of movement in the market for them to continue to offer it up as a service. And if the number of companies that are still expanding upon it continues to broaden enough to compensate for the dip in the number of companies evaluating it, trying to figure out if it's something, then it probably has some sort of stability there, and there's some equilibrium that has to be met. But whether or not just that flatline sustainability is enough, like have we reached enough in this market for them to continue offering it up as a service? And I think that's something that's interesting to pay attention to. A lot of services you'll find with like Azure, there have been a lot of services that just kind of come and go, right? They just they're there, they're offered, they don't really hit the market all that well, so they have to take it out. So we'll see. We'll see if this is something, and I think that's kind of a fear. It's another one of those things that people are thinking about when they're trying to figure out if they're going to do serverless. The stateless nature of serverless platforms makes it difficult to support applications that have fine-grained state sharing needs. So state sharing means like I've got this data that I need all of these functions to have access to. And that's another challenge of these serverless functions. How do you get all of them to like have this data that they're all connecting to? And you could have some sort of like message queue system or like database up in the cloud that they're all getting their data from, like Firebase or something. But then they're not actually in memory. They have to keep accessing that outside resource to go get access to that data. Whereas with a regular application, obviously you have like data loaded up in memory that the whole application can gain access to. So that can slow down the process, right? If you're talking about data access, it can definitely slow down those processes. So this is mostly due to the limitations of existing storage services offered by cloud providers. Okay. Serverless computing must also grapple with the risks inherent in both application disaggregation, what a word, multi-tenant resource sharing. So I think what they're getting at here is there's multiple users using the same service, right? So my company is also using the same service that this other company is using. And so we have the same computer, the same hosting service, and the same computer server that's processing this. That has to be balanced, right? How do you grapple with that? Berkeley researchers now. So here's where they end kind of on a high note. Berkeley researchers are highly optimistic about serverless. Quote, serverless computing will become the default computing paradigm of the cloud era, largely replacing serverful computing and thereby bringing closure to the client-server era, they predict. So that's, I think that's pretty bold. I think somebody was getting a little bit philosophical there, and they're kind of projecting what they hope and what their dreams and what their desires are. Because I think it comes down to how much money can these companies make off of this? Like, it's a great idea, but are they making money? That's the thing. Because these companies are not going to continue to offer service if they're not making money off of it. And if we're starting to see kind of this downward trend in businesses that are deciding to pick it up, maybe the market has already started to flatten out, and you've probably barely even heard of the process, right? This may be the first time you've even heard of this idea, and already companies are starting to like level off their looking into this. Whereas the companies that did embrace it, right, they're expanding. And again, does that mean that it'll start to branch out? Because sometimes that's what happens. Sometimes a service is so good, and a small group of companies or organizations latch on to that particular service, and it grows from there. And then it becomes so popular because of this that it just keeps going on. But I also think that part of this, that one thing that can't be overlooked, is how embedded these types of systems are with your Internet of Things, right? So all of your Google Minis, your Google Home devices, your Amazon Alexas, if you're going to be doing any sort of Internet of Things, like BlackBerry Pis or something, having these like serverless things that can be communicated to and talked to are really kind of where that's the bread and butter for this particular service. So if you're really into those types of Internet of Things type of gadgets, right, then this makes total sense to use and is very easy to integrate. So there's still kind of that little bit there that can be held on to. As long as we have these Internet of Things, that's going to be a market, right? Then we're going to continue to see these services be provided. Okay, let's see what we have in the form of questions. Let me see. Oh, what? Unable to connect. Hold on. Let me see. There we go. Hello, Steve from Qatar. Hey, Mustafa. Mustafa, good to see you again, buddy. Wow. Awal says, watching live from Ghana. Mustafa asks, question, your feedback on Firebase Firestore for commercial use. So Firebase is pretty mature. And this is really good tie into, again, Internet of Things. Like, what kind of database can you use to communicate back and forth? And Firebase is a really good solution for exactly this. Like, There's event-driven data storage and stuff like that. That's just it's really good concept, and Firebase is really kind of the leader in this right now. So that's really good. I think that as far as for commercial use, yeah, I don't see any problem with it at all. If there's so many different database solutions out there, I think Firebase is really good because it's this system that you can tie into from just about anywhere. Like, you don't even need a back-end web API if you're using Firebase. Like, that's pretty cool. You just build like a front-end application with JavaScript, HTML, CSS, and just use some JavaScript code to go talk to your Firebase and go and access it. There is some security-related things that you kind of have to worry about with that, though, right? You can't just let anybody gain access to your data and start messing with it. So, but yeah, I think Firebase is a great solution. I've tinkered around with it quite a bit, and I think it's great. I still think that it's better to have some sort of full-fledged API, some sort of web API or RESTful API service that's acting as your business rules. You still kind of need that layer in there, right? You still need to have that ability. Okay, well, that's going to do it for me. Thank you so much for having coffee with Steve. I hope you guys have a wonderful rest of your day. Thank you so much for joining. If you're interested, by the way, in becoming a member, it's only $5 a month. You just go to the programmingmadeeasy.com website, and that'll just redirect you back to the YouTube channel. You just click on the join button, and when you click on that, you'll have access to things like direct contact with me. There's a form that you can fill out, and you can ask me questions directly. That's pretty cool. I know that's a lot of you guys. You guys ask me questions in the comments, and I just simply don't have the ability to get to all of them. And really, it's not a very good venue for answering questions like that. So with this form, you can give me your database if you're working on something, or your source code, or you can take screenshots of what your screen looks like and send me those questions directly, and I think that's a much better way. And then, of course, you have access to, you'll get mentioned actually at the end of every one of these videos, which reminds me, I need to do that for you wonderful people who are already members. I should probably, I gotta be more prepared for these things, don't I? I gotta stop waking up like a half hour before and just start, I'm gonna turn on the camera. Let's see, what do we got? Where's my, so you also get 10% off my Teespring store. So if you're interested in getting any sort of, I got cups, I got t-shirts, I've got towels, I got all sorts of stuff in there. And you guys get 10% off if you're a member. So definitely it's worth it there. Because, I mean, just buying one thing makes the $5, right? So who can we thank for being members? I'll tell you what, the latest person we got was Cormac, who's been talking to me a little bit. So thank you very much, Cormac, for signing up. Then there's Ron Howe, HRU, which is Henry, HRU Bricks, Jim Griggs, Samuel Nictesia Tabiri. Boy, that name is always going to trip me up. For Technical, Kanan, Rishi, SAA, which is Steve. Nice to meet you. Mrs. CY, I'm so fly, and Olubayu Olasakin. Thank you guys so much for being members. I really appreciate it. We're already up to, Olubayu's been a member for 23 days. So he's got everybody beat so far. We'll see how long Olubayu lasts, and I'm really interested. Olubayu, one of these days you're going to have to swing by. You're going to have to say hi to us here in our morning coffees and let us know how you're doing. Anyway, I think I'm going to go ahead and wrap it up there. Thank you so much, guys, for joining us, and I hope you guys have a wonderful day.